All right. So let's review that perpendicular bisector. Okay, here's my segment. First of all, kind of eyeball where you think the middle is. And then on this side, I'm going to highlight that yellow. On the other side, I'm going to highlight it pink. You don't have to, but for my demo, I'm going to do that for you. It'll be easier for you to see. Okay. I'm also going to show you another way to do it in case you like this way better. It's very similar. Okay, so earlier we had the arcs, right? Just like a big half circle. So we're going to put our compass on A. And then, do you see this yellow area? Kind of about right here where my pencil is, roughly. I want it to go through there. So look, that's about maybe what, number 5? Yeah? 1, 2, 3, 4, 5. Okay. So I'm going to take my pencil. Watch what I do this time. Instead of just making an arc and going like that, I'm going to go all the way around and I'm going to make a full circle. Some of you might find the full circle easier to do. If you don't like the full circle, I'm not going to make you. Okay, then I'm going to turn it over. I'm going to turn my paper around like this. And I'm going to do it again. I need to know the same hole. Like, what hole did I use? I got to do it again. This time, put my compass on B. 1, 2, 3, 4, 5. Okay, now when I draw the circle, obviously the circle goes off my paper. Yeah? But essentially I have 2 ginormous bug eyes. So instead of a bug, I have bug eyes. Personally, I don't care which one you draw. It doesn't matter to me. Okay? Once you have that drawn, these intersection points, do you see these? I want you to draw a vertical line. So you're going to line those up with your compass. And I want you to go past it, way above it, way below it. Okay, don't just stop at the intersection points. Okay, so there's that, right? And again, if you're someone who just wants to make the bug looking arcs, you can. But some of you might find that easier. Okay, so we have this here, right? So this point in the middle, anybody know, you remember what that is? It's in the middle. It's in the middle.
Midpoint.
Midpoint, okay. Woo! All right, midpoint. What does a midpoint do? It indicates that it's exactly in the middle of 2 endpoints. So this side, AM and MB are congruent. They're the same size. If you were to take your straight edge and you look right here, if I were to measure that, I've got 3 centimeters. And then if I go on this side, I have 3 centimeters again. By the way, if you do that, and you're like, well, one's 3.5 and one's 2.5, that means you did something wrong when you drew it. Okay? That would be a drawing error. It should be exactly in the middle. You can verify it by measuring. All right, the other thing I want you to draw is a right angle. Okay? So, because this line is a perpendicular line. In fact, it's a perpendicular bisector, which is a perpendicular line that cuts a segment into 2 congruent halves. Okay? It's a perpendicular line. A perpendicular line that cuts a segment into two congruent halves. So, you guys remember that, right? Well, we're going to build on that today. When you're done writing that, put a circle or put a dot up here, the top intersection, and I want you to label that as C. Put a capital C. Okay, and then I want you to take your straight edge, and I want you to draw a dotted line. Yep, draw a dotted line that way. And then draw a dotted line the other way. So C to A and C to B. Okay? Now, take a look at your picture. Take a look at your picture. Okay, how many of you think, just looking at the picture, how many of you think that those diagonal lines, these dotted diagonal lines, how many of you think that those are congruent lines? Raise your hand. How many of you think they are not congruent? Okay, let's try that vote again before I start calling on people. How many of you think that the dotted lines are congruent? They're equal. If you were to measure them, would they be equal? Raise your hand. Okay, how many of you think they're not congruent? Okay, so let's test that theory. I'm going to measure from A to C. I'm using the millimeter side of the arm. I got 3.5. Okay, so over here, I'm going to measure from C to B. Oh, look, I got 3.5 again. So now, I just proved to you that they're congruent, right? Okay, so I want you to put 2 tick marks on that side and 2 tick marks on that side. Okay, so these lines are congruent as well. That means that M is the same distance from A and B. It's directly in the middle. Well, so is C. It's the same distance from A as it is from B. Okay, now, if I were to measure this line right here, if I were to go from the top to the bottom, so from C to M, would that be congruent to going from M to C? If I start here at C and I go to M, is that congruent to when I go M to C? Would it be the same? Yeah, of course it'd be the same. I'm going to put 3 little marks there. Okay, when you look in the mirror every morning, you equal yourself, right? You don't equal somebody else, you equal yourself. This is reflexive. That's like it's reflecting back on itself, right? Okay, think about it like a reflection in a mirror. Okay, I need you to understand that I drew C up here where the intersection is, but I need you to understand that any dot, and there are an infinite number of them, any dot on this perpendicular line is the same distance from A that it is from B. And I just proved it to you. Do you see what I did? Like, I proved it to you. And there's other ways I could prove it to you if I added numbers and stuff, but we could do Pythagorean theorem. Okay, but I just showed you a quick measurement. Okay, so any line any dot on this line. If I draw a line from there to A, then it's the same distance as from there to B. Does that make sense the way I said it? Pretty much? Okay. All right, so this is our main focus. So perpendicular lines are lines that intersect at a 90-degree angle. We already have that drawn on there. The symbol is this, upside down T. Some people include the little right angle, some people do not. Okay. Perpendicular bisector theorem. And then, oh look, converse of. So we're going to write out the theorem and then we're going to write the flip-flop. Okay, before we do that, we're going to come over here.
Sorry, what's that symbol again?
This
Yeah.
means perpendicular.
Sorry.
Okay, look, guys, you see this triangle here? And this triangle here? Okay, you're not going to draw a line to connect the triangles, but if you put your ruler, your straight edge, up against that little peak of your triangle, okay, I'm going to draw a line that starts above and goes just below the top triangle, and then I'm going to do it again down here. Right above to right below. Okay, so now, without doing the compass thing and the measuring and the protractoring and all the stuff, those are perpendicular lines. Like, we could measure them. They're probably 90 degrees. For our notes, we're just going to go with that. Unless you are like seriously wonky like that, then those should be perpendicular. Okay, we're going to put our little right angle on both of them. And then you see the 1, 2, and 3 tick marks that we did up here?
Yes,
And the A, B, C, M?
yeah,
Go put those on here. So you're going to have A, B, C, and then M is in the middle. Pretty much. A, B, C, M. Then you're going to put your little marks. Okay. Don't put marks along the entire length of a side. Just put the 1 mark, the 2 mark, the 3 mark. Don't go all the way down it. If you're someone who likes color, you could, okay, well those are congruent, and these are congruent, and this is congruent to itself. So you can do that. There's nothing wrong with that. The tick marks, they take less time, but some of you really like the color because it is good for your brain. Okay, we got all that, right?
yeah.
Okay. So, here's the official stuff, like the official geometry that we got to know. If a point, like, you know, like point C, if a point is on the perpendicular bisector of a segment, then it is equidistant from the endpoints. What does equidistant mean? What does equidistant mean? Equidistant. Equal what? Equal distance. Very nice. And by the way, I just want to say to you, do you see the word bisector? That's actually a really important word, because could I draw a perpendicular line, like right, don't do this on your paper, but could I draw a perpendicular line right there? This little one? Could I draw a perpendicular line over there? I could. Would that be a bisector? No. So the word bisector indicates where that line is. It is exactly in the middle. So that word bisector is really important. Okay? So what that means for you, what this means for you is, okay, if CM is a perpendicular bisector if this line is truly a perpendicular bisector. Then AM is congruent to MB and AC is congruent to BC or CB. Okay, so if this line is truly a perpendicular bisector, then these parts are congruent and these parts are congruent. So that's the perpendicular bisector. And then again, if you're someone who wants color, so those and those, you don't have to color anything. Okay, you don't have to, I'm just showing you. Everybody got that?
Yeah.
So we're going from the perpendicular bisector, okay, to the congruent segments. Now the flip-flop of that, the converse of that, okay, if a point is equidistant from the endpoints of a segment, then that point lies on what? The perpendicular bisector. We're just going to flip-flop it. Okay, so down here, what it means for you is if AM is congruent to MB and AC is congruent to CB, so if the green parts are congruent to each other and the orange parts are congruent to each other, then what? CM is, what do you think it is? Perpendicular bisector. You can't leave bisector off. It is perpendicular, but don't leave the word bisector off. That right there. Yes. Okay. Huh? No, I didn't.
On the right. On the right.
These are all capital letters. I just wrote them small. All of my letters are capital. And yes, to answer your question, it does matter. Capital letters let you know you're talking about a point, capital block. Capital cursive, you're talking about a plane. There's a difference. Lowercase letters are usually sides, like lowercase block, but lowercase cursive is a line. Do you remember in Unit 1 where I kept like really just nagging you about the style of the font and the size of the font? That's why, because they all mean something. Okay, now we have 3 examples to practice. Okay, and then whatever time is left is yours to do your homework. Okay? All right, here we go. Ready? I'm going to show you what this looks like in actual everyday practice. Okay. Use the diagram shown below. Okay. BD is the perpendicular bisector of AC. We are telling you that that is a perpendicular bisector. So, that means these two are congruent. These two are congruent. Look where I'm putting my little marks. And then these two are congruent. Okay, so here's Okay. Everybody got all that?
Yes.
All right. So now this is how this works. It says suppose that ED is 16. I'm going to come over here to ED and I'm going to write a little 16. ED equals 16. DA is 20. So I wrote that down. And it says find DC. That, my friends, is X. So I'm going to put an X right there on my picture. Okay. Everybody in the room, do you know what X is without doing any work? Everybody raise your hand if you know what it is. Okay, tell me what X is. 20. Now, there's a very particular way we got to write it down. Are you ready? We have to do this first. We have to say that AD is congruent to DC. You have to tell me that these two sides are congruent. You have to like physically write it down. And then you can say X equals 20. So you got to have that part first, and then you can say that part. It's kind of like preheating the oven before you bake a cake. You did? You didn't bring me any?
I bring in spice cookies. Give me extra credit. like a full batch.
No, but you will be my favorite.
I get tech. Have you ever tried banana bread before?
Yes. Okay. I like banana bread, yes.
Well,
Okay.
I could make banana.
You can?
Yep.
That's awesome. All right, guys, let's do this next one. BC is 15. I'm going to write this down. Oh, EC. My bad. Look, I almost put it in the wrong spot. EC is 15. BA is 25. And BC is X. Okay. All right, everybody. Do you know what BC is? Just looking at the picture.
Yes.
Yeah, you sure do.
Yeah.
But you got to write it a certain way.
AB. Congruent.
Lovely. AB is congruent to BC. Now you can write X equals what?
15.
No.
Equals 25.
Yeah, 25. Okay, remember, these diagonals are the ones that are congruent. That's why we make those marks. Okay? Now, guys, it's not always going to be just a visual thing. Sometimes you're going to have to do some actual computations. Turn your page. Okay. I want you to write this down over here.
Oh, it's not that bad.
Oh, what do you mean not this again? This is all year. This isn't going anywhere.
Really? It's a table.
Okay.
Yes, I do remember, buddy.
You know how Pythagorean theorem is like a squared, b squared, c squared?
Yeah.
Do you remember when I said that a couple years ago I figured out that this was more helpful to a few students?
No.
And then this is kind of stuck? All right, so I like that. All right, here we go. Look right here. We got these. We have these. Yeah? And we have this.
Oh, really? No one made.
I know.
Oh, goodness.
Okay, so it says AD is 10. Label the 10. It says that BD is 6. Label the 6. Then it says to find the length of AC. Ladies and gentlemen, right here, to go from A all the way to C. Okay? However, in order to find AC, In order to find AC, I just need this piece right here. Because if I know halfway, what? Great, I can multiply by 2 to get the whole thing. Exactly. And in order to get this halfway, I need Pythagorean theorem. So which one of these are we going to use?
The first one.
Yes, very nice. Okay, so right here, we're going to say AB, that's the leg. That's my leg. Equals the square root of, oh, you know, we should do this. Ready? AD squared minus BD squared. Is that the geometry or the algebra? Yes, geometry. Okay, what do we put in that now? Okay. So AD is a 10, so you can write 10 squared, minus BD is a 6, you can write 6 squared, and then AB equals, can you type all that in the calculator?
Yeah.
You can. Type it in and give me an answer.
Louder.
64.
There you go. What? How did you get that?
Wait,
Maybe not. There you go.
I put in the calculator wrong.
Okay, try it again.
Oh goodness.
Negative 26.
Okay, I should see everybody
That's
putting this in the calculator instead of some of you waiting to, okay? How many of you got 8? Okay, those of you that are a little lost right now, your calculator is doing this. 10 squared is 100. 6 squared is 36. 100 take away 36 is 64. And those are all under that square root symbol. The square root of 64 is 8. And my answer does not have a square root symbol. Okay, I need you to understand something in geometry. Sometimes your answer is a whole number. Sometimes it might be something like this. It might be, it might look like that. Okay? So if you're using the NumWorks calculator or the NumWorks app on your phone when you're at your house, you can also get to it on the computer. But you might get an answer like that. That's not wrong. Okay? So just so you know. All right, my friends. You have a homework, yeah?
Yeah.
Okay.